Okay, now that we have our artwork done, we're going to go ahead and start scripting our artwork to get some animations and functionality. First thing I want to do is go to Assets, right click, and create a new folder. Store my scripts. Double click on scripts, right click, create a new script. And let's call this first script Slingshot. Take the Slingshot script and drag it up to the game object Slingshot. Verify we have it. Then I want to go to launch point. And in launch point, I want to add a new component. In this case, it's called, under effects, halo. Give it a color that's visible regardless of the background. And set the size to 3. Now, before we do anything further, let's make sure we save this scene, because by default it doesn't save when you run it or when you go and start creating things in Visual Studio. So we don't want to lose that new script in Halo. Double click on Slingshot script. Oops, sorry. There we go. And what we're going to do is check for a mouse over event on our Slingshot. So let's go ahead and create 2 new methods. The onMouse enter method and the onMouse exit method. We're going to print into the console on mouse enter when the mouse enters, and on mouse exit. When the mouse leaves. Again, pause there for 1 second. Go ahead and click save. And go back over, go to your console window, run it. Now, down here, this is your information, but that's turned off by default. So what you're going to want to do is click that, make sure it's got a slight highlight, and then when you mouse over and mouse out, you'll get your 2 messages proving that our mouse enter and mouse exit events are firing, which allows us to progress to the next step. So let's go up. A couple things. First of all, if you look in the book, the author has actually used a transform. So on page, if you have the book, it's great. If not, it's not a big deal. But on page 504, the author actually uses a transform, or searches for a transform in the script. He then looks for the game object that transform is attached to, and then he sets the entire game object to false, so it turns it off. He could have easily just used a find for the game object and turned it off, which I'm not sure, or used this.setActive and turned it off. Now granted, this.setActive would apply to any script that, or any game object the script was attached to, but again, a couple of weird things that he had done here, and I'm not exactly sure why. He also stated that Halo isn't accessible programmatically, which again is not true. It's a behavior. So what we're going to do is a little differently than what's in the book. I'm going to bypass the bizarre transform search and not use the game object search or even the game object that the script is attached to, but I'm actually going to use the behavior and enable and disable just the behavior, because that's kind of ultimately what we want to do here. So first thing I want to do is go up to the top and just create a quick variable to store the behavior. Then I want to create a new method, awake. And in awake, what I'm going to do is go ahead and search for the launch point game object and get the behavior and then turn the behavior off. So now notice we don't use type, we use the name of the behavior, not the type of the behavior. Also notice that I had to go find launch point. If I would have just placed the halo on the slingshot instead of the launch point, I would not have had to go through this process, right? I could have just grabbed the halo directly from this game object. But that, again, that's not a big deal, just kind of odd. Let's go ahead and turn it off. And by the way, every coder is different and unique in their own way. And no code will ever be the same, so not a big deal. Okay, on our mouse enter events, mouse exit events, what we want to do is actually just turn the halo on or off. Go ahead and save all. Go back to Unity. Go ahead and run the project. Notice it turns off our halo. If I mouse over, enter the space of the launch point, it turns it on. And if I leave, it turns it off. Okay, let's go ahead and launch our projectile from our slingshot. So we'll go ahead and go back to our slingshot script. Add a couple more properties up at the top. Okay, we'll load this after done coding in the inspector. We'll make these changes in code. Now our wake method, let's get the position of the launcher. Create a new method down here for mouse down click event. So what this is going to do is when somebody clicks the left mouse button, we're going to set aiming mode to true, and we'll actually then go into the updates a little bit later and check to see whether or not aiming mode is true, and if so, we'll run some extra code. Okay, create an instance of our bullet or projectile we're going to shoot from our slingshot. I'm going to start it at the launch position location. This basically stops the projectile from reacting to other objects, temporarily, for now. Go ahead and pause if you need to, and update, and then save. We'll go over here. Go to our slingshot. And notice we currently do not have a profile, or excuse me, a prefab for our projectile. Don't drag it and drop it over here to the projectile. That's actually dynamically created in code. So what we want to do is go to our prefabs, find our projectile, and drag it into our prefab. Okay, sorry about that. We have some code issues. Let me check our code real quick. Oh, sorry. I'm going to change this a little bit because of how we're going to go about it. I'm going to change this to launch point. Okay. What was happening is I wasn't actually getting the position of launch point because launch point wasn't yet instantiated. I was using launch point game object or geo inside of the awake method. So if you go ahead and make those two changes, just get rid of the geo for game object here and here. Everything else should work just fine. And you'll see that it's going to use this game object now instead. Let's go back to, oops, hang on, save it. And then run it. Go into your sphere here and click the left mouse button, and you should see your projectile appear in the slingshot. Let's go ahead and add a couple more variables real quick. First is the velocity of our projectile. Go ahead and put it under set and inspector. Oops. Has a velocity multiplier, and we'll show you what that's going to do. It's going to actually affect how fast the projectile fires from our slingshot. We also want to go down to dynamic and add the rigid body. And that's for our projectile. Go to on mouse down. Okay, we've already set is kinematic true to the rigid body of the projectile, but in the book it's having you, if you have the book in front of you, it's having you do this again. We're not going to do it twice, but we are going to go ahead and pull over the projectile's rigid body into a variable. Okay. And then we're going to go and update method up here on the top. And we're going to go ahead and ignore the update code that I'm going to show you below this line of code if the left mouse button has not been clicked. So again, if the left mouse button hasn't been clicked, just leave the update method immediately. Okay, grab the mouse position in its X, Y coordinate. We're going to update the Z coordinate with the Z coordinate of the camera. And this is a line of code. I'll explain to you what it does here once I'm done writing it. Okay, so this line is basically taking the current mouse position, which is going to be 523 by X and then 272 Y. And it's going to take it relative to the camera view and give me a new position. So thereby allowing me to get an XY coordinate, again, relative to the camera point, starting 0, 0. So I'll be able to have 4 quadrants around that camera, and it will update the new position with a much smaller, more localized set of points. The reason that's important, by the way, is I'm actually going to look for deltas, position of the current mouse versus where the launch point is. And that's going to give me a basically a magnitude of thrust and or power and direction that I'm going to send the projectile. And you'll see that code here in just 1 second. Let's go ahead and get the vector. 3. Hang on, mouse, the delta, sorry. Again, current position in the new world view relative to the camera, minus the launch position. Okay, we're going to get the sphere collider radius, which I believe was 3. And that is going to be a max magnitude. Basically, when I left click the mouse, I don't want the projectile to go outside of that radius. So I'm looking for the maximum radius that I can use. Okay, what this is doing is taking the mouse delta and it's normalizing everything to 0. So what I'm going to do is multiply mouse delta times max magnitude, which gives me that outer ring limitation that I'm going to have. And you'll see how this works. When I left click on the mouse inside of the halo, it's going to actually position that projectile wherever my mouse is relative to that new world XY coordinate. And it's going to continually looking for the magnitude of that XY position. And basically what that is x times x, y plus y times y plus z times z squared. And that's going to give me a value. And if that value goes above 3, this if statement is going to lock it so it won't go beyond 3, because max magnitude is 3. So if we normalize mouse delta and normalizing, setting everything to 1, and then we multiply x, y, z coordinates by 1, that's going to give us our maximum magnitude of 3. It's a little confusing, but it's pretty straightforward. If you just do some debugging and follow the code, you can actually see what it's doing. Problem is debugging this, if you put a breakpoint in, you have to understand you're hitting every single update on the mouse. So it is a little difficult to debug. Let me finish that statement. Okay, let's go ahead and move the projectile to that new position. And then finally, look to see whether or not the mouse button is released. And we're going to check for input get mouse button up. And if it is, go ahead and fire off the projectile by setting a velocity, turning kinematic off, and then destroying or turning aiming mode false and destroying the variable or nullifying the projectile variable. That's not going to get rid of it in screen or in game. It's just for this code, so that you can get ready to fire off the next one. Okay, and what we're going to do is check for the farmost left mouse button, which is 0. It's probably an enumerator, but I'm not sure what it is. This stops update from running the code. This allows the projectile to now start interacting with other objects, other game objects. Okay, this is that delta again. And again, the delta is determines the position currently of the mouse and, by definition, the projectile. Probably better the projectile. And the launch point. So it's got a distance and also a direction with the vector that it wants to go. So it knows how far away it is, and it also knows which direction to go. And there's actually in the book, there's kind of an explanation of how it works, but unfortunately, in my opinion, the way they wrote that in the book is actually a little off because you're not firing the ball off to the left. But it's a similar concept. You can actually go in and change velocity manually. Just go ahead and put vectors in here, like 10, 10, 10, and you'll watch it fire off at like a speed of a bullet to the, up and to the right slightly, and just fly indefinitely, or for way beyond what you would be able to see on the screen. But what we're going to do is go ahead and take that, because by default, that distance and that direction the direction is accurate, but the distance isn't enough to really give it enough oomph. So what we have is we have that velocity multiplier, 8f, that we created earlier, and we're going to multiply that delta times that number. What that's going to do is, again, it's going to give that projectile more oomph to fly further relative to the distance that it is from the launch point. Okay, I haven't tested it yet, but let's go ahead and save it. Okay, hang on, make sure it's saved again. Okay, go ahead and run it. Once you're running, go ahead and go down to your slingshot, go ahead and left mouse, and you'll actually be able to move the projectile around within your little sphere of halo. And again, relative to the position of the launch point, it's going to multiply that delta times 8f, and it's going to launch the ball in that direction. Okay, that's the start of our game. Let's go ahead and pause there for a minute. I'm going to go back to the code. I'll just leave it there. Go ahead and pause if you want to check to see if you made any mistakes. If your game wasn't running like you expected, you can also rewind and go back and pause at any point in any of the code. I'm actually going to stop here, create a video. We're 30 minutes in, and I'll create another video after this one to finish up the game. Okay, a little bit later, we're actually going to reset back to the slingshot. Just wait a few minutes for that, or a little bit for that. But what we're going to do now is actually change the orthographic camera view so that the ground is always visible, and fix a few other issues. So go ahead and go into your scripts. In your project view, right click, create a new script, and let's call it cam or follow cam. Drag that script up into your main camera. Make sure it's there, which it is. Go ahead and double click on the script to open it up in Visual Studio. And first we're going to add a couple variables. This would be what we want to follow. the Z position of the camera. And we're going to do the fixed update so the ball travels at the same speed regardless of the machine. Let's stop in the event that a object is not selected to follow. Okay, this is actually by default going to be the projectile that we're going to follow, and it's going to be a little jumpy because what's going to happen is as soon as we fire the ball, it's going to put the position of the orthographic camera on that projectile. So let's go ahead and make that work, run it one time, look at the physics involved, and then make another change to make it smoother. So go ahead and run, or not run, open up the Slingshot script. Should be open up here. Scroll down to your update. Look for the mouse up event. Right below our velocity. And I noticed that I'm missing a line of code here. So let's go ahead. I'm not sure. Maybe I put it somewhere where it didn't belong. Not a big deal, just to free up the projectile variable for another projectile in the next update. Go ahead and save that. Go back to Unity. Again, I'm not saved here, so I'm going to go ahead and save it real quick. And go ahead and run it. And then throw your ball, or your projectile. Again, remember it's going to be a little jumpy. We'll fix that in just a minute. And also, the ball is going to fall forever. Okay, so the ball doesn't fall off the end of our platform. Let's go ahead and make the platform a little larger. So click ground. And let's go ahead and set ground position. Let's move it over a little and then increase its size. Okay, that fixes the problem of us losing the ball in below the ground. Okay, let's go to the projectile prefab. And let's change our collision detection to continuous speculative. Okay, that'll help with visually making the ball or the projectile look a little more realistic. We also want to go ahead and lock it so that it doesn't roll to infinity, and also so that it doesn't fall forward or back from the camera view once it hits an object later on in the game. So click on the constraints, and let's go ahead and freeze the position of Z, and also stop it from rotating so that it doesn't roll as far. Also, let's give it a little more realism in terms of physics when it lands or hits an object. So let's go ahead and go to our materials and create a new material. But this time, instead of a regular material, we want it to be a physics material. Let's call it PMAT projectile. And then in the inspector, give it some bounciness, value of 1. And then set that material to our prefab projectile. Here's our sphere collider. Go ahead and select it, and you'll see the material. If you run it now, you'll actually see the ball bounces, but I'm going to go ahead and make a few more changes. So let's go to our follow cam again. Okay, what we're going to do is we're going to lerp between two locations, and what that is basically doing is slowly moving an object towards another object, and I'll explain that in just a second. Okay, what this is going to do is basically take a vector, and it's going to take in this case, the transform position of the camera and the destination, which is the current position of the projectile, and it's going to calculate a point in between to move to a new location. Easing, for example, if it was 0.25, would be 25% of the distance. So if you wanted to jump 4 times before, or 3 times before it gets to its destination, just go use 0.25. I updated it to 0.01, which means 1%. So it's going 1% towards its destination each time until it finally reaches its destination. Now I'm going to go ahead and save this again. Go to my scene, and in my scene, I'm going to save my scene. Go ahead and run it. Fire off my projectile. And notice my camera can't keep up. It's moving, it's lerping too slow. So we're going to go back to our code. And we're going to change it to 0.3. Save. Run. And test. Still a little too slow. Yeah, way too slow. So we can play around with it until we get, I think they have 0.5 in the book. I think that might be too fast. Okay. Okay, so we have a 0.01 here. In my code, we have a 0.05. Let's put a breakpoint here. Go ahead and connect it to Unity. Go ahead and run it. And it's stuck on the settings set in the properties window. So what we're going to do is make a change real quick. Go to main camera. Get rid of that value. Let's see if that gives me the view that I'm looking for. Nope. Okay, no problem. For right now, we'll just go ahead and set it here. And there we go. Okay, I'm happy with 0.303, which is 3%. Let's go ahead and save our scene. And let's go back to our follow cam and put constraints on our camera. And we'll match this to our inspector properties window. The zero method simply zeroes it out to 0, 0 for XY coordinates. Okay, go down to your destination and let's put some constraints in. Okay, that will lock it from going backwards. It will also lock it from going down below the board or the platform. Okay, so next we're going to go to the camera and we're going to adjust the camera out so that the orthographic size of the camera expands as the projectile flies away from the slingshot. Okay. Let's go ahead and get rid of our breakpoint here. Save. Okay, go ahead and play. And I'm going to fire our ball straight up in the air. Okay, I'm going to stop it one more time and just show you the constraint. If I fire the ball, oops, backwards. Notice it didn't follow the ball going backwards. Okay, now we're going to go ahead and create a cloud and then move that cloud through the scene and randomly create clouds as well. So let's go ahead and start by creating a sphere. And then you'll see my spheres right here, right? So we want to go ahead and take the transforms, make sure they're located, which they are, right in front, right where I would want them in the middle of the screen. And let's call it a cloud sphere. Then let's create a material and call it matte cloud. Okay, let's go up here and give it a kind of a grayish color, like a light gray. And then go up to your shader, and in the drop down, actually, oops, sorry, let me go back to my material. Had a little bit of a delay. Go to your legacy shaders, self-illuminate, and diffuse. And this way it'll react to outside lights as well as producing light itself. Go ahead and take your cloud sphere and drop it down into your prefabs. And then delete cloud sphere from your view or from your hierarchy. And create a new game object. Just create empty. Let's call it cloud. Go to scripts, create a new script called cloud, and add it to our cloud object in the hierarchy. Let's open up the cloud script and go ahead and add some properties. Okay, go ahead and pause there and copy that. Then we'll move forward. Okay, let's go down to our start method. And let me move up so that we'll have this quite a bit of code that I'm writing here. So oops, got a couple typos here. I messed that up here, so let me look. Yep, I put 2, my apologies. You'll have to fix that. That should be a Z, not a 2. Okay. Go ahead and just type out all that code. You can pause here, and then we'll go ahead and do our update and our restart in just a minute. By the way, all this is doing is creating a random number of those spheres of various sizes with various Z levels to kind of create this layered effect to create a puffy little cloud. It's not perfect, but it's just something quick to make you know, a little bit of motion on the screen. Yeah, let's go ahead and go do our update. Ah. Sorry, I got hung up there. I messed that up big time. Okay, so in the event that you hit the space bar, we're just going to go ahead and restart the clouds. Okay, and now we have to create the restart method. I'm just going to go ahead and destroy each one of the spheres in our cloud. And then we're going to go ahead and restart this class. Oops. Go ahead and save it. Go back over to Unity. Go ahead and go over to our cloud, and you should have a cloud sphere property variable here. Just go to our prefab and move our cloud sphere over to that location. And then hit play. And there's your little cloud. Cute. Okay, let's go ahead and make more clouds and also move those clouds around. So let's go ahead and first take this cloud and make it a new prefab. Then go up to your hierarchy, delete cloud, create a new empty game object, call it cloud anchor. Go to scripts, create a new script, and we'll call it Cloud Crafter, and add that Cloud Crafter script. It would be a second script to our main camera. So you should actually have two scripts on your main camera. Double click on Cloud Crafter, open up Visual Studio. And let's go ahead and start our variables. Okay, go ahead and pause there. Make sure you don't have any errors, and that you got all your variables created. Now let's go ahead and randomly create our clouds. Now start looking at the screen more often. Okay, give me 1 second. Okay, somehow I got the wrong method here. Okay, everything else looks good. Go ahead and pause there. Make sure you got all the code working without any errors. Okay, now that we have all our clouds created, what we want to do is move those clouds through the sky. Larger clouds are going to be moving faster than the smaller clouds. So let's go ahead and go down to our update method and write a little bit more code. Okay, make sure you take a few minutes to verify all your code is typed in correctly. I'm just going to go ahead and slide it up here and pause. You can pause. I'm going to go down to the next update. And I'm going to hold there, go ahead and pause. And again, what this is doing, just creating random groups of those clouds. And then update is moving those clouds slowly through the sky. Okay, let's go ahead and run over to Unity. Go to your main camera, and you'll notice currently you're missing the cloud prefab. So go to your prefabs window, grab your cloud, and drag it, or actually just go to main camera. And you can select from here and go to assets and select cloud and then run your game. Wow, it's a big cloud. And then you can go ahead and fire off as many balls as you want.